101. But the for loop is executed so many times because of the for loop, right? We need to iterate, I don't know how many based on the limitation or the test criteria. So what we're gonna do, if I is equal to 0 and then I smaller than n, I plus plus. So I am just giving this generic example first. While we are looking at the analysis of the algorithm, we generally look at how much time it takes for the loops, okay? So look at it here. Three things we first pay attention, right? What is the first thing? When it is start, right? It starts with the I equal to 0. Then the second thing, where it is ending, right? And the third thing is, what is the increasing rate? Everybody with me? So, in the first situation, when I is equal to 0, we can have a multiple statement. It doesn't matter, okay, right now. Assume that there are all the statements, okay, in here. 1, 2, 3, we don't care. We can just count as a 1, okay, right now. So, in that case, when I is equal to, we iterate one time, right? When I is equal to 1, again we iterate one time. When I is equal to 2, it's just go to up to where? When I equal to n, right? So, how many times will it repeat?
N number of times.
So, the runtime therefore what? O(n). Does it make sense?
Yes.
Okay, let's do something. If we change it, I become I plus 2. Okay? Everybody get it? I become I plus 2. We start from the again 0, this time again n, this time it will go to where? The increasing rate is what? 2, right? Rather than 1 by 1, this time 2 by 2, right? Okay. So I become first of all 0. This is the first iteration, right? In the second iteration, I become what?
2.
2. In the third iteration, I become what?
4.
In the fourth iteration, I become what?
6.
You see that this is going, let's say that we repeat k times. If we repeat k times, I become what?
Okay.
Look at this. If it is 5, I become what? 8 something, right? Let's go into this way. So assume that it's like, if you assume, I understand your things, but think about it. If it is 2, it's become 2. If it is 3, it's become 4. If it is 4, it's become 6. You see this? It's like going, what? 2 by 2, right? Assume that if it is k plus 1, let's put the k plus 1, it's become what? I become 2 times k, right? And look at this. K minus 1 times 2, right? Does it make sense? How many times we repeat? Let's say that k times. If we know the k, we know the runtime. Everybody with me?
Yes.
I know that if it is 2k, and this is the stop point. When the 2k is equal to n, it just stops, right? So, if 2k is equal to n, then k is equal to what?
N over 2.
N divided by 2. So the runtime is going to be?
N over 2.
Do we care about the constant? We don't care about the constant. It can be n divided by 1 million. Do we care?
No.
No, because n can be what?
Any number.
10 power 10, 10 power 20, 10 power 100, right? In that case, 10 power 100 divided by 1 million, theoretically, we don't care. In performance, it may be different, but in theoretically, we don't care. Therefore, this one is equal to what? Again, O(n). Does it make sense? Understood?
Why is it more?
Because we don't care about the n divided by 2. This is equal to 1 times 2 times n, right?
Yeah.
We don't care about the constant.
Oh, okay.
It can be 1 million, it doesn't matter. It can be 1 million times, and again this one is equal to what? Okay? So let's look at the nested loop. Everybody understand this one? Understood? Do you have any question? Okay. Let's do another example. This time it is a nested loop, okay? Nested loop. For I is equal to 0, I smaller than n, I plus plus. And then inside the 4 we have another 4, j equal to 0, j smaller than n, j plus plus. Okay? So you see that this for loop has another 4. Understood? When the I is equal to 0, this for loop is executed how many times? N times. When the I is equal to 1, this is how many times it is repeated? N times. You understand? We are counting how many times each are iterated, okay? So therefore, when the I is equal to 0, this one is, let's say that with general, okay, n times. When the I is become 1, this is repeat again n times. When the I is equal to 2, then it's repeat n times. When the I is equal to 3, again n times. It is go to up to where? When the I is equal to n, again n times. Then we sum all of them. Because it is not 1, 1, 1, 1, 1. They are execute n, 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 n. Does it make sense? How many n we have? N. So therefore the runtime is O(n) squared. Understood? Any question?
So we have to out the square, it's not a constant thing, right?
No, no constant thing. We just write the n squared. What happens if I change this one to this? I equal to 0, I go to up to n, I plus plus, but this time j starts from where?
0.
R. Whatever the I value, it is going to be j start from there. Don't forget, you need to be careful. Where it is starting, where it is ending, and what is the increment rate. Does it make sense? So in that case, when the I is equal to 0, how many times this one is repeated?
N minus I.
And that's what n, okay? When the I is equal to 1, it repeats how many times?
N minus 1.
N minus 1, very good. When it is I is equal to how many times?
N minus 2.
When I is equal to 3, how many times?
N minus 3.
When I is equal to, let's say that n minus 1, how many times it repeats?
N minus 1 in parentheses.
When I is equal to n minus 1, it repeats how many times?
Once.
Just once. So you see that how many we need to do? This is the number of the sequence, right? Number of the statement is actually executed. So the sum of it is actually give me what? The runtime. What is the sum of it? You know that? Do you know it? Basically this one is not like this. The sum of it is exactly the same this one or not? Isn't it?
Yeah.
Is it?
Yes.
This one is like a 1, this one is 2, this one is 3, 4. Like I am looking at from the reverse, okay? Basically this one is plus n minus 1 and n, like it is. It is going like this, right? Or you can have the n minus 2 in here, and then so. Does it make sense? So this, the sum of it, of this one is actually the sum of this one. What is the sum of this? From the high school math, what is it? 1 plus 2 plus 3 plus 4 plus 5 plus, what is it? What is it? 1 plus 2 plus 3 plus 4 plus 5 is equal to what? Bye-bye.
15. It's 15.
Not the factorial, it is multiplication. This is plus. I mean, Anastasia says this one.
Oh, okay.
This one is okay, 5 factorial, but this is not this one. This is sum. What is the rule, guys? Okay, that's fine. It's 1 plus 1 plus 2, 3 or more? 6.
6.
10, 15.
Oh, you got it. Okay. What is the rule? What is the last element? The rule is say 5 times the last element divided by 2. We are saying? Right? 5 times the next element will be 6, right? So 5 times 6 divided by 2. Everybody get it? If it is the case, this will be what?
N times n plus 1 divided by 2.
N times n plus 1 divided by 2. So the runtime for this is actually n times n plus 1 divided by 2, which is equal to what? N squared divided by 2 plus n divided by 2, right? Like this. Which one has the most significance?
N squared.
N squared. So get rid of this one. Do we care about the constant?
No.
So then this one is actually again the runtime for this one. Make sense? Understood? Okay. So this one is extra information because you should know this one from the high school. Therefore, I will give you my bank information so that it is an extra deposit you need to pay me in addition to your tuition.
You gonna pull it out of the space ATM?
Yeah, please use the space ATM. Any question, guys? You understand? Okay. So then, if you don't have any question, let's code a little bit.